Let R denote the set of all real numbers and let I equal the square root of -1. Consider the matrices S and T as shown. Let A, B, C, D be real numbers such that S times T equals the matrix A, B, C, D. Let H be the set of complex numbers X plus I, Y, where Y is greater than 0. Which of the following statements are true? Option A, the fraction B plus I, A over D plus I, C equals I. Option B, if omega is the complex cube root of unity, then the fraction A omega plus B over C omega plus D equals omega. Option C, if m is an integer greater than 2, such that st squared equals st to the power of m, then m is a multiple of 8. Option D, if z is in H, then the fraction az plus b over cz plus d is also in H. First, let's calculate the product of matrices S and T to find the values of A, B, C and D. Multiplying the rows of S by the columns of T, we get the matrix 0, -1, 1, 1. Comparing this with our given matrix, we find A equals 0, B equals -1, C equals 1, and D equals 1. Now let's evaluate option A. We substitute our values of A, B, C and D into the expression. This gives -1 over 1 plus I. Multiplying the numerator and denominator by the conjugate, 1 minus I, we get -1 plus I over 2. This is not equal to I, so statement A is false. Next, let's check option B. We are given omega, which is a complex cube root of unity. Substituting our values into the expression gives -1 over omega plus 1. Using the property that 1 plus omega squared equals 0, we can replace omega plus 1 with minus omega squared. This simplifies to 1 over omega squared, which equals omega. So statement B is true. For option C, we need to find the powers of matrix ST. Squaring ST gives a matrix with -1, -1, 1, 0. Cubing it gives minus the identity matrix. Therefore, ST to the power of 6 is the identity matrix, meaning the powers repeat in a cycle of 6. If st squared equals st to the power of m, then m must be of the form 6 lambda plus 2. If lambda is 2, m is 14, which is not a multiple of 8. Thus, statement C is false. Finally, let's evaluate option D. We are given a complex number z in set H, meaning its imaginary part y is positive. We substitute our values into the expression for w, which simplifies to -1 over z plus 1. Replacing z with x plus iy and multiplying by the conjugate, we find the imaginary part of w is y over x plus 1 squared plus y squared. Since y is positive, this entire expression is positive, meaning w is also in set H. Therefore, statement D is true. The correct statements are B and D.